Okay, so today's lesson will be recorded. If you don't want to be recorded, please just send me a question in the chat. And today we are talking about friction. And friction is the force that opposes motion. So something that is moving, right, in a direction. So this thing here is just moving in that direction. If it's on a rough surface, there's going to be bumps on both sides of the object. So these bumps are going to rub against one another in here, and that's what creates the friction in the opposite direction. It's always in the opposite direction of motion. Always in the opposite direction of motion. So if you're on an incline and the object is resting on the incline and the only force is the weight, so we have our weight in the x component, that's going to pull it down the incline. Friction is going to work up the incline and stop it from moving. Now if you have that same situation, right, and we have Wx, but this time you're applying a force, and F applied is greater than Wx, then friction is down the plane. So it depends on which way it's moving. So if it's moving down, like over here on the left, friction would be up. If it's moving up, then friction is down. So it always is in the opposite direction of motion. There are two types of friction, and you probably learned this in your video coming into class, but we'll go over it briefly. We have static friction, and that's the force, right? These are the two types of friction. Static force opposing start of motion. So if you have an object at rest on a surface, so V naught is equal to 0, and then you apply a force to it, F, now the object has a velocity. This force F has to be greater than Fs, the force of static friction, right? That's Fs. F must be greater than Fs to move. The formula for Fs equals mu s times n, where this is the coefficient of friction. It's a Greek letter, mu. And the coefficient of friction is how rough or smooth a surface is. How rough or smooth. The higher mu, more mu means more friction. Bigger mu equals bigger friction. So that's first type of friction, static friction. The second type of friction is kinetic. And this is the force that stops objects that are moving. So same thing, right? We got an applied force here. Let's say the acceleration in the x is positive. So that means it's going that way. Fk would be in this direction. So Fk slows the object down. It slows object. And the formula for kinetic friction is Fk equals mu k times the normal force. It's a K. Mu s is always greater than mu k. It's harder to start something moving than to keep it moving. When you're doing your homework problems in your book on page 169, has some common mu values. So if it says like wood on wood, you got to go to page 169 and look up the mu value for wood on wood, or rubber on concrete, things like that. So when you're doing your homework, page 169 will give you your mu values. When solving friction problems, you're always going to use three equations. We'll call these the big three. Number one, sum of the forces in the x equal max. Number two, sum of the forces in the y equal may. And number three, F equals mu n. Now this can be S or K, depending on the surface. So when you're solving friction problems, first thing you want to do, draw your diagram, your free body diagram, and then two, write big three. And then you solve for the unknown. And it could be from any of the equations. So those are your 3 steps to solve friction problems. Is there anyone that has anything they need clarified before we try to solve some problems? I just went through the background. That's from those lectures, in the chapter lectures that talks about the friction. Now these are some of the, these are tricky sometimes because you got to draw the pictures, you got to remember the normal forces and so on and so forth. So what we're going to do is just start. We're going to actually take problems out of the book. So if you have your book handy, use this time to get it open, because we want to make, we want to take, it's easiest to find problems out of the book. We're going to start with number 4 on my page 188. It says, suppose you have a 120 kilogram wooden crate resting on a wooden floor. What maximum force can you exert horizontally on the crate without it moving? If you continue to exert this force, once the crate starts to slip, what's the magnitude of the acceleration? So the first thing we're going to do is draw our free body diagram. So whenever we draw free body diagrams, we're always going to have 4 forces. We have the applied force. We're going to have the force of friction. And in this case, in part A, it's static friction. We have our weight. And we have our normal force. Most friction problems will always have those 4 forces acting on the object. So it says, suppose you have a 120 kilogram wooden crate. There's the mass. And it says a wooden crate on a wooden floor. So that's wood on wood. So I look on the chart. Wood on wood is 0.5 and 0.3. So that tells me mu s is equal to 0.5. Mu k equals 0.3. Notice mu is unitless and directionless. It's just a description of the surface. That's it. It's not a vector, it's just a description. So now we have our picture in part A. They say, what force can you exert horizontally without it slipping? So our goal is to find FA. Now, without it slipping, this tells us that the sum of, or excuse me, this tells us that the acceleration in the x equals 0. This I know. This FA that we solve for is going to cause impending motion. That means that anything greater, any force, I should say, any force greater than FA causes it to move. So we're going to find out what FA is, and it's assumed that any force greater than that causes it to move. To solve these problems, we use the three equations. Sum of the forces in the x equal max. Sum of the forces in the y equal may. And Fs equals mu s times n. Don't forget we found these values earlier. Our goal is to find FA, so let's go to our x equation. We say FA minus Fs equals 0, right? We know AX is 0. We have two equations in the x, FA, or two forces, FA and Fs. We can see that FA is going to equal Fs. Anything greater than what Fs is causes it to move, and that makes sense. Let's go to the y. What do we have in the y? Well, we have n and w. W, we remember, is equal to mg. So in the y direction, we have n minus mg equals 0. Ay is 0. This object is not accelerating up or down. N equals mg. N equals 120 times 9.8. Oh, what's that? $1176 newtons. Now we have n. We can come up here and find Fs. Fs equals 0.5 times 1176. 588 newtons. And now we can take our answer for Fs, plug it in over here, and find FA to equal 588 newtons. So any force greater than 588 causes the motion to impend, or for the object to move. I feel like I went really fast there. Does anybody have anything that I didn't make a good explanation on that you're wondering about? So part A says, find the horizontal force. Part B says, if you continue to exert it, this force, once the crate starts to slip, what's the acceleration? So in part B, right, we know what FA is. FA is 588 newtons. Now it's moving, so we don't have Fs anymore, we have Fk. We know the weight is 1176 newtons. We learned that last time. And we have our normal force. And we know the mass is 120 kilograms. Now, in part B, they want to find AX. It's no longer 0. So we go to our three equations again. Sum of the forces in the x equal max. Sum of the forces in the y equal may. Fk equals mu k times the normal force. Well, mu k, if you remember, 0.3. Let's go to the x again. Our goal here is AX. FA minus Fk equals max. We don't know what Fk is, so we can't solve that yet. Let's go to the center equation. We know Ay is 0. So we have n minus 1176 equals 0. N equals 1176 newtons, just like last time. Now we can take that, find Fk. $352.8 newtons. Take Fk from over here, plug it in there. and we have 588 minus 352.8 equals 120 AX. AX is equal to 1.96 meters per second squared. So that's our first friction problem. Anybody have any questions on that? You sure? All right, let's try another one. Let's try number well, I don't know what that force is there. Hold on. Well, we'll just make up some numbers here. So we're going to look at number 19 on page 189. And, oh, there it is. It's right above it. It says, we're going to do 18. It says a contestant in a winner, 18 and 19. Well, 19, we're going to do 19B, but it's off of 18. This is a contestant in a winter sporting event pushes a 45-kilogram block of ice across a frozen lake as shown. Calculate the minimum force F he must exert to get the block moving. What is the magnitude of the acceleration once it starts to move if that force is maintained? So here we go. This is actually 18B. The picture's with 19. That's why it's confusing. So we have a block of ice. There's a force being pulled up here at an angle of 25 degrees. Call that F. We know the block of ice is 45 kilograms. So the weight is 45 times 9.8. So the weight is 441 newtons. So in part A, we are looking for the force to get it moving. So in part A, AX equals 0, it's not moving. And we're looking for F to start it moving. And this is ice on ice, so we go back to our chart. And for ice on ice, 0.1 and 0.03. So mu S is 0.1, mu K is 0.03. Now remember, F is broken into two components. F cosine 25, F sine of 25. We still have two more forces we have to add. We have to add the normal force, and we have to add the force of static friction, really far away for some reason. So that's our free body diagram for this picture. Now it seems pretty easy, but it's not as easy as it appears. Let's see if I can move it. I have trouble moving it with this. Oh, look at that. Because I'm going to need all the space I can get. I made it bigger. I don't want to make it bigger. All right, anyway. Now, we're going to have three equations again, just like every friction problem. Three equations. We have the sum of the forces in the x equal max. Sum of the forces in the y equal may, and fs equals mu s times n. Those are our three equations. So just like last time, let's start going through and seeing what we have. We know ax is 0. So we have f cosine 25 minus fs equals 0. We know ay is 0. It's not going anywhere. So we have n plus f sine of 25 minus 441 equals 0. So we don't know either of those. We can't solve either of these. We don't know n, and we don't know f. We don't know f, we don't know fs. But what we can do is set up a relationship to isolate f. We can solve the first equation for fs and the second equation for n, set them equal to each other by the ratio mu s. So let me show you how to do this. If we rearrange this equation for fs, we have f cosine 25 equals fs. And then in the middle equation, we have n equals 441 minus f sine of 25. See how I solve for fs and n? Now I can plug them in to this third equation. So that gives me f cosine 25 equals 0.1 times 441 minus f sine of 25. And this is where I'm going to run out of room, I think. Now how many unknowns do I have? Just one. All I got over here that I don't know is f. So I'm going to distribute this 0.1 across, and that will give me f cosine 25 equals 44.1 minus 0.1 times f sine of 25. Next, I'm going to group like terms. So I add 0.1 times f sine of 25 to both sides. And that gives me f cosine 25 equals 44.1, plus 0.1 times f sine of 25 equals 44.1. Because remember I added them. So this is where I'm going to run out of room. So I'm going to have to move it up here. Sorry. Let's move this whole thing up if I can somehow manage to. That's not what I wanted to do. Let's move this bottom line up there. So we're going to take this bottom line and just move it up here. What I'm going to do is I'm going to factor out the f when I move it. So that's going to give me f times the cosine of 25 plus 0.1 times the sine of 25 equals 441. So F equals 441 divided by the cosine of 25 plus 0.1 times the sine of 25. F equals.
Is it 44.1 or is it 441?
44.1. Thanks. I lost that decimal, didn't I, when I moved it? $44.1. I got 4.65 newtons. Well, that doesn't seem right. Let me try that again. Yep. 46.5, excuse me. 46.49 newtons for my force. 46.49 newtons. Do you have any questions on that? That's part A. Does anybody have any questions there? Nobody? So then you can do part B on your own? Now part B, in part B, remember mu k is 0.03. So this becomes Fk. And that's the only thing that changes. Right, so down here, this is Fk. And they want to find the acceleration. What's the acceleration? So when you do your equation, sum of the forces in the x equals max, you now have Fk. So you got to come over here. The force you already know, you just solved for it, 46.49. So you got to go backwards a little bit. So I've done the hard work for you. You essentially have the same equations, except this is going to be max. You still have this equation. This doesn't change. And then this is Fk equals mu k times the normal force. Those are your three equations. So let's see if you guys can find the acceleration at your seats. So what I'm going to do now is show you how to do this. If I can remember. So the first thing we want to do, we want to say the sum of the forces in the x equal max. F cosine 25 minus Fk equals max. Sum of the forces in the y equal may. F sine of 25 plus n minus w equals 0, right? It's not going up or down. And then our third equation, Fk, that's a k, that is a k, Fk equals mu k times n. So we need to use n here, find n in our second equation. N equals w minus f sine of 25. N equals, let me get my numbers here, back from the old problem. 441 minus 46.49 sine of 25. $421.35. So FK equals 0.03 times 421.35. FK equals 12.64 newtons. Now I have FK, I know at F, I know M, I can find the object's acceleration. So I have 46.49 cosine 25 minus, change the color on me. Must have bumped it with my hand. 12.64 equals 45 times AX. AX equals the difference. 46.49 cosine 25 minus 12.64 over 45. AX equals 0.66 meters per second squared. How do we do? Anybody get it right? Close? Give me a thumbs up if you got it right or got close. We're on the right track. Nothing? Nobody got close or we're on the right track at all?
I got like 14 like 0.1 for the force. But I'm trying to
Which
see if
force? FK?
I'm trying to think if that was. I don't have a good calculator, so I kind of have to round.
Yeah, I got 12.64 again.
If I rounded, like, would that cause that to be off a little bit?
I got the same numbers, probably, but that seems like a lot, but
Yeah.
it depends where you round it at. Do you have the right idea, though? This is a hard problem. Really hard. You wouldn't see anything that's hard on the test, but there's one like this on maybe on the homework. Ready to try another one, class? Give me a thumbs up if you're ready to try another one. I don't know if anybody's even here. Nobody's doing anything except Julian. Oh, sorry, we're on a recording, except for JT. All right, most of you at least let me know you're here with the party balloons, party favors. Let's try another one. Oh, where do we go from here is the big question. I picked out a bunch of them. Let's do an angled one. 12. Number 12 on page 188. It says if an object is to rest on an incline without slipping, then friction must equal the component of the weight of the object parallel to the incline. This requires a greater and greater, oh, I don't want to do this problem. Boo. Delete this problem. That's like a proof. Which one did I pick out? I wanted to do one on an incline. All right, let's try 10. See how that one goes. 10 says, calculate the deceleration of a snowboarder going up a 5-degree slope. So we got our incline. We know this is 5 degrees. Assuming the coefficient of friction of waxed wood on wet snow. Waxed wood on wet snow, that's 0.1 mu k, right? We're decelerating, so you know it's mu k, kind of written into the question. Show that that's it. So that's all we know. That is all we know. We don't have a mass here, and you're going to see that that doesn't matter. So let's draw our free body diagram. We know we have, oh no, that's the eraser. We know we have the weight. We know we have Wx in this direction. So we're slowing down, and we have friction in this direction, Fk. Is there any force pulling us up if we're just slowing down, if we take our foot off the gas pedal, so to speak? There is no force pulling us up the incline. And our acceleration is going to show us that we're in that direction. We have a normal force, and we have Wy. What is our acceleration? How much are we slowing down going up this incline? So we can draw out our free body diagram here. W, remember, that's equal to mg. So this is mg. This is 85 degrees. So Wx is equal to mg cosine 85. Wy equals mg sine of 85. We know the object has a mass m. We have our 3 equations. Some of the forces in the x equal max. And our goal here is to find ax. We have Fk equals mu kn. And some of the forces in the y equal may, or we know ay is 0. So let's start up here with our x equation. We have negative Wx. I'm just going to go right into what I found it to be in the picture over here. Negative mg cosine of 85 minus Fk equals max. All right, we got to find Fk. What is Fk? What you're going to find out is we need to find n before we find Fk. So an n minus mg sine of 85 equals 0. N equals mg sine of 85. Plug that in over here. Fk equals 0.1 times mg sine of 85. And remember back when I said we don't need the masses? This is why. If I come up here, I say negative mg cosine 85 minus 0.1 mg sine of 85. I don't like how I put those brackets. Equals max. Well, what happens to the m's? They cancel right out. We divide each one by m, they all cancel out. So that gives us an equation for ax. Ax equals negative g cosine, well, g is 9.8. Let's put that in there. Negative 9.8 cosine 85 minus 0.1 times 9.8 sine of 85. I put the g in the wrong spot. Sorry. So ax equals, and I made that 58 for some unknown reason. The acceleration in the x is negative 1.83 meters per second squared. That's how much we're slowing down as we go up the slope. That's our rate of deceleration. Hopefully you're seeing that being able to draw your free body diagram makes your life very easy, because then you just pick out your x and y's, right? You pick your x's out, you pick your y's out, you group them together, and you solve. The more free body diagrams you draw, the better you get at it, the easier your life's going to be. Skipping that picture makes this next to impossible. Anybody have any questions there? All right, we are going to try one more. I don't know, there's just not a ton of great problems in the book for you to work on, besides the homework problems. And just do something. We'll try to do two. I'll just make a problem here and see if you can do the math. So we have an object on the surface. We'll say it's 40 kilograms. And I'm going to apply a force. Sorry, I got a little tight here. Apply a force of, I'll make that 40 degrees, of 60 newtons at 40 degrees. If mu k is 0.25, what's the acceleration? Try that at your seats. I'll draw the free body diagram to help you if you're stuck. We have 60 cosine 40 and 60 sine of 40. Normal force, the weight, (392 newtons), and Fk moving backwards on us. So a couple of you are finishing up, so I'll just finish out the problem. Sum of the forces in the x equal max. Sum of the forces in the y equal may. Fk equals mu k times n. 60 cosine 40 minus Fk equals max. N plus 60 sine of 40 minus 392 equals 0, right? We're not accelerating in the y. N equals that's not right. No. 353.43. Fk equals 0.25 times 353.43. $88.36. I'm seeing a problem here. 60 cosine 40 minus 88.36 equals 40 AX. Well, AX equals negative 1.06. Is this possible? No. This object cannot be moving with 60 newtons. This happens sometimes when you make up problems on the top of your head. But if you did all the steps correctly, that's what we're worried about. But in this case, the object wouldn't be able to move. Did anybody get all the steps correct and get negative 1.06? Anybody? Thumbs up if you got it. Nobody got 1.06? Oh, one person, good. Couple people, hopefully. All right, one more. We got time for one more. We got to do as many of these as we can because they are not easy. And this one's like the lab. When you do the friction lab, you're going to have to do a problem exactly like this. So I'm going to show you how to do it. You have an inclined plane at some angle. Let's make it easy, 30 degrees. And this time we know the mass. Let's make that 25 kilograms. And the question is, what does μs have to be for this object not to slide down the inclined plane? So AX equals 0. So this is static friction. Our free body diagram, we have WX, WY, the normal, static friction. Our goal is to find μs. We can draw our little free body diagram, right? 25 times 9.8, that equals 245 newtons. This angle is 60, so we got 245 cosine 60 and 245 sine of 60. Our three equations. Sum of the forces in the x equal max. Sum of the forces in the y equal may. Fs equals μs times the normal. It's an equilibrium. It's not sliding. Fs minus Wx equals 0. Fs minus 245 cosine 60 equals 0. Fs equals 122.5. In the y, n minus wy equals 0. N equals 245 sine of 60 212.18. What's mu s? Well, that's Fs over N. 122.5 over 212.18. 0.58. And this is how you do your friction lab. This is how you do the math for it right here. Just like this problem. Do you have any questions there?